With this lesson, we're going to start talking about the networking or the core networking services in the cloud. So first, we're going to start talking about the virtual private cloud or VPC. Now, a VPC is a virtualized network construct made available by a cloud provider, and it offers private network space to the users of public cloud platforms. So basically, a VPC provides the ability to define and control a virtual network that one can use with isolated and logically segmented services and applications within a public cloud environment. Now, VPCs are basically composed of subnets, and these are range of IP addresses in your VPC. So when setting up a VPC, you can specify its IP address range from any range you choose, and you can divide this range up into multiple subnets. We also have route tables, and these contain a set of rules or routes that are used to determine where network traffic from a subnet or gateway is directed. Now, internet gateways allow you communication between instances in your VPC and the internet. Now, virtual private gateways, on the other hand, allows the VPC to connect to other networks, especially on-premises data centers using VPNs. We've also got elastic IP addresses, which are static public IPv4 addresses that you can allocate to your provider's account and associate with your instance if you're using maybe AWS, GCP, or Azure, for example. We've also got security groups and network ACLs. VPCs are also composed of VPC peering, which allows you to connect one VPC with another in a single region, and also VPC endpoints, which enable you to privately connect your VPC to supported AWS services, for example, and VPC endpoint services powered by AWS Private Link, for example. And we've also got the NAT devices or NAT gateways, and these are used to enable instances in a private subnet to initiate outbound traffic to the internet for updates, patches, and so on, but also prevent unsolicited inbound traffic from reaching those instances. Now, let's assume a company named TechFlow, for example, that wants to migrate their web application to the cloud. So to set up their VPC, they first create a VPC with a specified IP range, and then inside the VPC, they set up two subnets. We've got a public subnet and a private subnet, and then they attach security groups to their web servers to ensure only HTTP and HTTPS traffic can reach them. And they can also set up a NAT gateway in the public subnet, and the database servers in the private subnet use this to fetch updates from the internet without exposing themselves to inbound internet traffic. And for added security, they establish network ACLs, for example, to allow only specific IP ranges to communicate with their public subnet. And to connect their on-premises data centers with this VPC, they set up a virtual private gateway and a VPN connection. So this setup ensures that while the web servers can communicate with the public, the database remains isolated and protected, and thus leveraging the benefits of VPC for real-world applications. So in essence, VPCs play a pivotal role in the cloud world by providing a blend of security, customization, and flexibility, and that ensures that even in a multi-tenant cloud environment, one can achieve a level of isolation and control similar to operating in a private data center.